and was transmitted some 10,000 to 3 million years ago, which is well compatible with the age of our fossil. We therefore find no evidence that hip osteoarthritis is related to our evolutionary history as long-distance runners or a common ancestor with racehorses. Another problematic zone is in our body is the shoulder. Shoulder dysfunction is the third most common musculoskeletal complaint. It is mostly due to subacromial impingement syndrome and increases in prevalence with increasing age. But age cannot be the only contributing factor because, for example, the Achilles tendon doesn't show similar problems. Therefore, variation in acromial shape and muscular disbalance have been implicated in the etiology of shoulder impingement syndrome. Variously, it has been proposed that humans have a small suprascapular fossa and therefore a small suprascapular muscle, supraspinatus muscle, compared to great apes, which might represent a contributing factor to the predisposition of subacromial pathology. Another study last year just reiterated this hypothesis. Which might predispose then the absolute size is, however, the relative size of the muscle. Here shown relative to the infraspinatus area. Blue here, humans, green, chimpanzees, and orange are orangutans. And we see humans are in the line with great apes. So they have very similar sized supraspinatus and infraspinatus muscles. Also, the subacromial space is not particularly small in humans. There is a large overlap between humans and great apes. Our shoulder problems are therefore probably not related to the reorganization of the shoulder during the adoption of bipedalism in human evolution. A third vulnerable zone is our spine. Back problems cause enormous health costs, and almost everybody will be affected by back problems once in lifetime. Contrary to common belief, twin studies showed that mechanic factors are just a minor contributing factor. More important is the genetic predisposition, and the majority, almost 60% of the inter-individual variants in this twin study remained unexplained and might be related to our bipedal locomotion. One of the hallmarks of bipedalism is the lumbar lordosis, which brings the center of body mass back behind the hip joint and thus allows efficient bipedal posture without much muscle work as in a chimpanzee here. Only 8 skeletons allow us to examine the morphology of the spine in early hominids. Almost all of them show pathologies related to biomechanical stress. In this Homo erectus boy, we found evidence for juvenile disc herniation. Lucy, Australopithecus africanus, was described to have Scheuermann's disease based on this ventral appositional bone growth, and the same pathology can be seen in this Australopithecus africanus skeleton. Then, well, we have the skeleton from the Manisi, which also shows a very elongated vertebral anteposterior size, suggestive of Scheuermann's disease. And we have here this Homo heidelbergensis skeleton, which suggests the lumbar form of Scheuermann's disease. Scheuermann's disease leads to hyperkyphosis of the thoracic spine in adolescence and is related to biomechanical stress during adolescence. And finally, we have here this last skeleton of an Australopithecus africanus, which was described to have brucellosis, but this vertebral marginal lesion is probably more likely to be caused by an anterior disc herniation. Thus, well, there are some additional isolated thoracolumbar vertebrae, and 4 of them also show evidence for Scheuermann's disease. In total, we have 6 to 8 individuals, early hominid individuals with Scheuermann's disease out of 22. Compared to 1 to 4% in modern humans, plus 1 to 2 juvenile disc herniations, which are quite rare in modern humans. In some, nearly half of the early hominin specimens were affected by some sort of biomechanical problems. And one explanation could be a relatively small vertebral intersectional area
Hey, just need to.
I got them.
You got him. Awesome.
What group are we on right now?
We're on the 1045.
Okay, they're on here.
So, awesome.
He's in here.
We just need to. Frank Rui.